The Philippines is not only about tropical beaches, it also hides mountain worlds that seem almost impossible to believe. Here, nature shapes life in its own way, where people adapt and survive against extraordinary conditions. Far from familiar routes, these mountain regions preserve a rare sense of wilderness and mystery. Towering peaks rise through the clouds, while deep valleys remain isolated by extreme terrain, creating landscapes that feel like another planet. Join us as we explore Impossible Philippine, a journey into some of the most incredible mountain worlds ever seen, where beauty goes beyond imagination. Osmeña Peak appears as a fractured limestone landscape, where sharp, repeating ridges reveal long uplift and subsidence of ancient seabed layers. The summit reaches about 3,350 feet and belongs to a karst system 20 to 25 million years old. Strong winds across narrow upper trails can generate slight lateral vibration, giving climbers a clear sense of open, exposed mountain space. Repeating points formed through limestone dissolution and long subsidence create a dense karst pattern shaped across millions of years. Peaks narrowing to 1 or 2 feet at the top give visitors a direct encounter with sharp terrain and the erosional power of nature. Pagsanjan Falls is known for a drop of about 300 feet, forming a strong water sheet inside an old basalt canyon. Mist creates a thick white layer, and small rainbows sometimes appear when light enters at angles near 25 degrees. Sound levels once measured between 75 and 85 decibels inside the canyon because echoes increase the force of the falling water. Local stories connect the falls with ideas of escape and inner strength from earlier communities. Visitors move close to the lower pool to feel the direct impact and find a steady sense of balance in the deep canyon echo. Taal volcano emerges as a forceful tectonic feature with a complex caldera and a young crater reflecting continuous change across many thousands of years. Geological records listing more than 30 major eruptions since the 16th century form essential evidence for understanding hazard cycles and surface change. Pulses of warm gas create light ground vibration and rising white plumes that visitors can easily observe with the naked eye. The 2020 ash column, rising nearly 9 miles with volcanic lightning, exposed extreme pressure capable of reshaping the landscape within minutes. Ground cracks widening more than 6 inches in 24 hours highlight the fragile boundary between stability and the natural warnings recognized by local communities. Mount Gwiting rises as a fractured ultramafic massif where ancient uplift carved sharp surfaces and steep, hazardous slopes across millions of years. Its ridge forms a continuous sawtooth line where closely spaced points highlight intense erosion and the hardness of the surrounding rock. The mountain reaches about 6,752 feet, with steep, broken faces, making the ascent one of the most technical climbs in the Philippines. A 2015 study reported exposed serpentine layers with unusually high nickel levels, creating nutrient-poor soils where vegetation struggles to anchor. Magnetic disturbance along the knife edge, where compasses shift 10 to 15 degrees, indicates strong mineral concentration and deep structural deformation. Mount Mayon stands with a near-perfect cone, where ancient lava layers formed a symmetric structure carrying strong internal geological force. Historic eruptions produced gas ash and rock flows, moving over 60 miles per hour, revealing unstable heat beneath the surface. Lava once exceeded 2,000 degrees Fahrenheit, creating dark vertical bands that reflect constant motion inside the magma system. In several recorded events, pressurized gas from the crater produced metallic, high-pitched sounds heard miles away, showing extreme internal pressure. Steep cuts and sharp rock surfaces make every step demanding as the terrain shifts continuously under weather and seismic influence. Mount Batulao displays deeply weathered basalt and andesite ridges that reveal how an extinct volcanic form continues to erode through long-term processes. In 2021, a terrain measurement detected 2 to 3 millimeters of lateral micro-shift on the western side, indicating long-term pressure from gravity-driven erosion.